All right, so we know how to compute the divergence of a vector field and its curl. We've talked a little bit about how you can interpret those computations when F is a vector field that's modeling, say, fluid. And so now we're going to get to a useful fact for us in this class. And so assume that the components of your vector field, P, Q, and R, are well-behaved, meaning for us, we want them to have continuous second-order partial derivatives. In that case, then you know that the curl of F is 0. Now, keep in mind, the 0 vector, because curl is a vector, so curl of F is the 0 vector if and only if F is conservative. And so we had a test for two-dimensional vector fields. We had a test to tell whether it was conservative. Let's actually write that old test down. We'll talk about the connection at the end here, but we had if F was just PQ, then F is conservative if and only if Q partial X equals P partial Y. That was for two-dimensional vector fields. In the three-dimensional case, you just compute the curl, and if the curl is the 0 vector always, then your F is conservative. And so if we go back to our previous vector field, we got this F, and this F, sorry, and we computed its curl, and let's actually just copy it down. So we got this for our curl, and so we wouldn't want to do pink. We said the curl of F equals this guy, and you can see right away this is not the 0 vector, right? You can plug in, unless you plug in 0, 0, 0, you're not going to get out 0. So this is not the 0 vector. So we can say thus F is not conservative. Okay, so let's do another example. Let's work out this one. So here's my F, and the curl of F we already know. The formula for it, let's actually evaluate it again. So I'm going to write my partial X, partial Y, partial Z. I'll write 6xy, 3x squared, and 1. And so now I can compute the curl of F, and I get partial Z of this guy, which is 0, minus partial Y of this guy, which is 0. So the first component was 0. Then I get minus, and I get partial X of 1, which is 0, minus partial Z of this guy, which is 0. So minus 0, I can handle that. And then finally, I get partial X of this guy, which is 6x, subtract partial Y of this guy, which is also 6x. And so the curl is the 0 vector. And so we can say, thus, our vector field F is indeed conservative. And I'll just mention to you here, just so that you know, right, F is conservative. F is the gradient of some scalar function. And in fact, we can write down what F is. Maybe you should pause the video and find F yourself if you have a little extra time. But either way, it's 3x squared y plus z. And of course, you can throw any constant that you like on there. I'll just put 0 on there. There we go. Okay, so that's that. Let's break this video here, and then in the next example, I think we will wrap things up.